Hey, how's it going, class? Welcome to your review video where we're going to be talking through this review assignment. This is kind of some of the bigger questions that I liked from looking at the previous tests, some of the things that I thought were more important. Now, I'm just going to work my way through this assignment in this video. You can use this to check your answers. You can use this to help you get unstuck. What I recommend you not do is don't just watch this video and copy down the answers, because that might help you get the assignment done. That is not going to help you in actually understanding it and doing well on the final. I recommend try your best to be able to do these problems without following me exclusively, because you are not going to have me on the final. You're only going to have a pencil and your brain. So let's take a look at this first question. Obviously, this one should be no surprise. You find yourself with the chance to play Mr. Curry's game. You will be playing with 3 dice and 3 quarters. And in order to win the game, you have to roll a prime number on all of the dice and get heads on all of the quarters. Now remember, we always want to read these questions 3 times. First time, we just read it, no intentions whatsoever. We're just reading and following along. Second time through, we want to go through and we want to see what information do we need. So you find yourself with the chance to play Mr. Curry's game. We hopefully, by this point, really know what is going on when we're playing Mr. Curry's game. Like, this one should be no surprise whatsoever. You will be playing with 3 dice and 3 quarters. In order to win the game, you have to roll a prime number on all of the dice and get heads on all of the quarters. So, kind of go through, we highlight all the information. We kind of figure out, okay, what is it that I'm looking for? Well, in this problem, I'm looking for the probability of winning given these rules. And remember, what's probability? Well, probability of event A is number of times you get A, or number of times A happens, over the total way things happen. Or the event divided by the sample space. Kind of bringing back that vocabulary, those definitions that we have. Well, looking at this, my probability, I need the total number of ways that I get 3 dice with a prime number and 3 heads. So let's kind of note up here to the side. Well, on a dice, the prime numbers are 2, 3, and 5. So on each dice, there are 3 prime numbers divided by the 6 total sides of the dice. And well, is there any difference between the first dice, second dice, and third dice? No, there is not. So we're going to take and we're going to multiply all of those dice probabilities together. And then we're going to think about, well, a quarter, there's 1 heads, 2 sides. So I get 1/2 for all of these. Now, you can take and you can just do this straight out. And maybe think about, well, what was that thing that we called this? We called this the multiplication principle. That the multiplication principle says that if we have a bunch of different probabilities, we can multiply those together to see what the probability is of this event happening that is made up of all these other things. And we can do this, we can multiply this value, and we're going to get 3 times 3 is 9, times 3 is 27. Divided by, well, we've got 6 times 6 is 36, times 6 is 216, times 2 is 432, times 2 is 864, times 2 is 1728. Go ahead, pause the video, go back, do that on your own, and double check that you understand where those numbers came from. But this right here is one solution. Because notice, I did not say in the question to simplify the probability, to convert the probability to a percentage. I just said, what's the probability? So you could do it this way. You're done. Good job. The other way you could do this, I'm going to change colors here, is you could think of this as the probability of winning is, well, I can simplify this, can't I? 3/6 is the same as 1/2. So here I really have 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times that final 1/2 that I have 3 dice and 3/4. So when I multiply these out, well, 1 times 1 times 1 times 1 times 1 times however many ones is always 1 divided by, and then we've got 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And well, these are the exact same answer. If you put either one on the test, you get full points. Whether you do the big expanded version or you do the simplified version, both are the same. But I want you to think about, why would you choose one over the other? What does this mean versus what does this mean? Is one of these more user-friendly to you? So pause the video. I want you to think about, what do both of these mean? All right, so now that you've thought about it for a moment, you've kind of broken it down, let's use what this means. So this is saying that if you were to play the game 1,728 times, you can expect that you should win about 27 times. Now, it's a probability. Probabilities are not certain. They are not real life. They are an estimate. They are a best guess. So if you play this game, you should expect to be somewhere close to 27. If you get 24, yeah, that's reasonable. It's close. Where you start to want to be concerned is if you play this game 1,728 times and let's say you win 100 times. That is extremely unlikely. In fact, that is pretty much impossible. Not entirely impossible, but it is so unlikely that you should not expect it. So that's what this one tells us. Now, if these are exactly the same, if these are equal, well then this has to be just a smaller number. This is saying that if you were to play this game 64 times, you should expect to win once. So, when we're thinking about that, let's take that knowledge and that thinking into the next part. So, for part B, I give you the opportunity to wager 1 point from this exam out of 50 points. If you lose the game, then you lose a point. If you win, though, then you get 5 points. Should you play the game under these conditions? Give a solid explanation. So, this is a really great question in my opinion, because if you understand the probability, you should very much so not be willing to play this game. But I want you to think about it. Would you? Because if you play once, then let's say you got a perfect score. You got exactly 50 points. Well, if you play this game and you lose, you're now at 49 points because you lose. That's one option. The other option is that you win, and now you have 55. That's the really easy way of thinking about it. But think again. You had to pay 1 point to win. So in reality, what's actually happening is you have the option of going from 50 points to 49 or 54. Now, in this case, it doesn't really make sense. You have an A already, so you don't need to worry about it. But when you're dealing with this thing, what happens if, let's say, you have a 45? If you had a 45, your two options are now, if you lose, you have 44. If you win, you could have 49. And you can kind of see how there's this difference of, well, you gain or lose, gain 1 point, or you lose 1 point, or you gain 4 points. Should you play the game? And maybe you're like, I want to risk it. You have a chance. But when we think about this, you should only expect to win 1 out of 64 games. It is very unlikely when you roll that dice that you're going to win. And it's like very quickly, as you're playing, if we think about this, if you start at 50 points and you lose 1 point, you lose another, lose again, one more time. At this point, if you won right here, you'd gain back all those points. That is the only time where it would benefit you. But in reality, you can really expect far more likely you're probably going to lose a lot more than just 4 times before you win again. So I would say no, I would not, because the expected value, the value that when you're thinking about this game and how it's going to go, the expected value is negative. As you're playing, you are not going to win very often. It is more likely that you are going to continue losing points than that you are ever going to gain enough to win. So no, I would not play because the expected value is negative. I'm going to lose more than I will win. So that is question 1, looking at Mr. Curry's game. That's the Unit 1 test stuff. So let's go ahead, let's take a look at question 2. Remember, we're going to try to read this question 3 times through. So a researcher is walking through the parking lot of a grocery store in the middle of the day. They are interested in seeing how many dark or light-colored vehicles there are and how many cars or trucks there are. The researcher counts 100 vehicles in the parking lot. Of those vehicles, 47 were a dark color and 31 of those were trucks. There were 43 more trucks in the parking lot. Let A equal the set containing the dark colored vehicles and B be the set containing the trucks. Complete the two-way table and the, typo, Venn diagram. So, as we're looking at this, we read it through the first time. And remember, that first read through, just read it. Second one, we're going to start to answer the question. we're going to pull out useful stuff. So, a researcher is walking through the parking lot of a grocery store in the middle of the day. Who cares? It gives us context to the story, but it's not necessary. They are interested in seeing how many dark-colored vehicles or light-colored vehicles there are. That seems pretty important. We've got our first binary thing. Is it a dark or a light-colored vehicle? And how many cars or trucks there are. We've got our binary, car or truck. The researcher counts 100 vehicles in the parking lot. Well, 100 vehicles, that's a total. And I happen to know I've got total here. So there's 100 vehicles in this parking lot. Of those vehicles, 47 were a dark color. And I can see that I've got that information right here. 47 of those were a dark color, and 31 of those were a truck. So I know that I've got 31 dark trucks. Well, when I'm looking here, I've got dark trucks. So I know this blank must be 31. There were 43 more trucks in the parking lot, 43 more trucks. Well, I can see that they already gave me that here in the table. And then they tell me let A be the set containing dark colored vehicles and B is the set containing trucks. Well, I can kind of just logic my way through this. I know up here they tell me the binary is dark or light. Well, color, I've got dark or, well, this must be light. Same thing on this side. I've got car or truck. I've got truck. That must be car. And we can just go through this and see, okay, I've got 16. I'm doing the operation of plus. So 16 plus something equals 26. Well, that something must be 10. And now let's just go through and let's check all of these. I've got 16 plus 31. Well, that's 7 and 4. So I get that 47. Awesome. This one is good. I know this one's good. I just used it. Let's see here. 31 plus 43 is going to be 4. 74. 10 plus 43, I get 53. Awesome. So I'm good here, 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 and here. Let's just double check here across the bottom. 47 plus 53, I get 0, 1, get a 10 there. And 26 plus 74, get 100. Awesome. So my two-way table is good. Now I'm going to take that information, I'm going to pull it over into my Venn diagram. So I know that all of the information in here, this section on the interior of my two-way table, that is all the information that makes up this entire Venn diagram. So I'm going to use that information to help me out. So let's see, dark cars. I'm going to go to dark, go to cars. There's 16. So that's my number right there, 16 dark cars. And let's see, I know A is the set of dark colored vehicles, B is the set containing trucks. So if I am in the middle of both of these, then I must be a dark truck. Then looking here, okay, light trucks. That's the next blank I've got. I'm going to go to truck, go to light, and I meet at 43. So I've only got a couple more blanks. U is our universe. There are 100 vehicles. That's our total here. So we've got our last category here. We've used these numbers. Well, 10's the only one left. That corresponds to light and car. So I've got my light cars here. Next up, so we've got our tables filled in. We double check them. They make sense and they fit logically with what we're doing. So we get to answer about some of these probabilities. So what is the probability that a dark vehicle is selected? So a dark vehicle is selected. So the probability of a dark vehicle. Well, notice the wording. We are only talking about dark colored vehicles, and we don't have any qualifiers. We don't have any conditions. So dark vehicles, let's see how many dark vehicles we've got. We've got dark and our dark vehicles. There's 47 of them. And what's our total? Our total is 100. So the probability of a dark vehicle is 47 over 100, which this one just screams to me. It's so easy. We can make it a percentage instantly. That is a 47% chance that you pick a dark vehicle. And that's a car or a truck. Next up, what is the probability that a light-colored vehicle is selected, given, that's a key word there, given that it is a truck? So this is where we have to switch up the way we tackle this because we are talking about something different. That given, first off, when I'm writing it symbolically, I'm going to say the probability of a light color with this bar here, given that it's a truck. Well, now I'm restricting myself. I'm saying, okay, given that it's a truck, I only care about this row here, the row of trucks. So I know that my denominator is 74. And let's see here, given that it's a light color, well, light color is this 43. So I get a probability of a light color, given that it's a truck, is 43 out of 74. And at this point, if you want to convert it to a percentage, go for it. You can do that with long division. I'm sure most of you are rolling your eyes right now just even hearing me say convert to a percentage. So pay attention. I don't say that. All I say is give me the probability. This is a probability. And it's always good. I always like to see the symbolic stuff here. So that's always a good thing to include as you're working on this. For those of you who really want to go above and beyond, you could do here that this is really the probability of A, and this is the probability of A complement given B. That's if you want to go above and beyond. So that is page 1. If you had any issues with this, if you're struggling to keep up with it, make sure come talk to me during office hours or lunch. That way we can get you squared away before the test on Friday. So let's take a look at this second page. First up, question number 3, we've got what looks to me like it's going to be a box plot problem. So let's read the question the first time, just trying to get the information. The following set is the lengths of the Harry Potter books in release order: Sorcerer's Stone, Chamber of Secrets, Prisoner of Azkaban, Goblet of Fire, Order of the Phoenix, Half-Blood Prince, and Deathly Hallows. And we've got the set H containing 223, 251, 317, 636, 766, 607, 607. A. Is this a well-ordered set? If not, then order it. So, reading back through that, the following set is the lengths of the Harry Potter books in release order. It lists out a bunch of titles. That information is useless. Who cares? Those of you who know about the Harry Potter books, great, that meant something to you. If you're reading this and you're like, I've never read any of the Harry Potter books, never seen the movies, you don't need to know anything. All of that information is just to give you context. What we really care about here is H. H is the set containing, and it lists out 7 numbers. Is this a well-ordered set? Well, we need to remember, what does it mean to be a well-ordered set? A well-ordered set is any set where the value to the right is always greater. Or in other words, as you're going through, do you start at a small number, and as you go to the right, does it get bigger? If yes, then great, it's well ordered. But looking at this, I've got 223 followed by 251. Good, that works. 251 followed by 317. Awesome, it works. 636 followed by 766. This is going really well until we get to books 6 and 7, where all of a sudden we go 766 to 607. So no, this is not well ordered. So we need to order it. So we would say that H, well ordered, is the set containing 223, 251, 317, 607, 607, 636, and 766. So now that we've reordered it, we can use that 5-number summary to go through and find our key values. Our first value here, the minimum, is the first value in a well-ordered set. It's our 223. Then I'm going to kind of skip around and go the maximum. Well, the max is the biggest value or the last value in a well-ordered set. So I've got 766. I'm just going to come in here and I'm going to use this blue pen to go through. Okay, the median, well, I know there's 7 Harry Potter books, so I've got n equals 7. If I divide that, or subtract 1, sorry, because I know it's an odd number, there's 1 middle value. I get 6. 6 divided by 2 is 3. So I've got 1, 2, 3, median, 1, 2, 3. So I've got a median of 607. Well, there's 3 numbers on either side of my median. So I've got 1 median, 1 to get that Q1 of 251. Because Q1 is just the median of everything to the left of the median of the total set. And Q3 is the median of everything to the right of the median. So I've got 1 median, 2. So I get a Q3 of 636. So I've got that 5-number summary, or the FNS, for those of you who don't like to write out long phrases here. So we've got our FNS. We can create a box plot. major point here. You cannot skip around on the scale. You need to pick a scale and stick with it. So we're going to give ourselves a nice number line here and pick our values. I am going to start here at 200, and I'm going to count up by 25s. It's going to give me a good adjustment here, but not too much to where I'm writing a ton. So I've got 200, 225, 250, and you want to do your best to make these kind of even. It's not the end of the world if it's uneven. And this is not the only way you could do this. You could count by anything that you want, so long as you are consistent. That is the key. You've got to be consistent in counting along this number line. And you might find you need to start over further. And you'll notice maybe I chose poorly. Maybe 25 is not the correct number to count by because you have to draw so many sections. That happens sometimes, but the key is you want to make sure that you're not going with too many sections, but you also don't want not enough sections. Because not enough sections is just as bad. You don't want a box plot where you're guessing almost everything that you're doing. $7.50, and we go off the page a little bit. So 223, I'm going to draw my line right about there. 251, draw my second line for that Q1. Then we got that huge jump up here to 607. Then Q3 is at 636, so little ways into that section. And then our max is out here at 766. Connect Q1 and Q3 to form your box. And draw your little whiskers out. And then don't forget to give these the label. So minimum 223, Q1 251, the median 607, Q3 636, and the max of 766. And let's throw a title on this thing. This is Harry Potter book lengths. And right here we've got an excellent mastery looking box plot. We've got a title, we've got our labels, we've got what looks like a box and whisker plot, and we've got our nice number line here. And then we see we've got this find the mean size of a Harry Potter book rounding to the nearest tenth. We call it the mean because it's mean of me to make you do it without a calculator. But it's good for us to take a look at it. So here we're going to take and add up all of these values. So I'm going to kind of zoom in here and start adding. 223 plus 251, 474. add our 317, 11, 9, 7, 636, 7, 2, 14, plus 766, get 13, 9, 11, 2, plus 607, 10, 10, 8, 2, plus 607, 7, 0, 14, 3. So I get that I'm going to take 3407.0, because I'm rounding to the nearest tenth. That is 1 decimal place. And dividing by 7. 7 goes into 3 0 times. 7 goes into 34. That is going to be 4 times, because it's not quite 5. So 34 minus 28 is 6. Drop down the 0. 7 goes into 60. Oh, let's see, that's going to be 8 times for 54. Subtract, we get 6. Drop down the 7. Get a 9. 9 times that is 63. 4. Drop down the 0. Get 5. So we get that the mean Harry Potter book size, X bar, is 489.5. And that is our box plot question. Once again, we haven't done this in a while. Make sure if you have questions, if you're watching this video and you are completely lost, come talk to me so that I can help you and we can get this figured out for the final. Last up, personally, one of my favorite sections. It's this most recent section we did of sampling types. So here, question 4, match the sample type with the appropriate story, and for each story, identify the population and the sample. So as we are looking at this thing, we've got a few different stories. So first up, every school district in Oregon has to select 10 students to be our state testing champions, and we use their scores to determine how well districts are doing. So, looking at this, we have a bunch of school districts. Hopefully by now you've figured out that the school district you're in is determined based on a trait. You all happen to live close to a certain point that we've deemed that is a school district. So we've taken and we've separated based on a location. Well, what kind of sample is determined based on location? Well, a location is a cluster sample. Cluster samples separate people based on where they are relative to other people or other individuals. So we got that first one done. Second up, someone is doing a giveaway on Twitter where you have to retweet to be entered. How do you hope they're selecting a winner? Well, we really hope that it is completely random, that there is no favoritism, no bias happening, which means we really want it to be an SRS. C. We want them to just take everyone who entered, put their name into a hat, and randomly pull out a number. On the bottom of my Chick-fil-A receipt this weekend was a survey for which I got a free chicken sandwich. Well, every single person who went to Chick-fil-A ever, on the bottom of their receipt, there is a little survey link. Anyone could do it. It is a general invitation. But not many people do it except for those who like free sandwiches. So it is voluntary. I chose to put myself into the survey, put myself into the sample. So it is B, a voluntary response. Next up, the first 100 customers entering Costco are asked to take a brief survey. Well, if Costco is looking for feedback, this is the easiest way. It's convenient to just ask the first 100 people. We always want to be careful, so careful. In fact, I'm going to red highlight this. Convenient samples are not good. They are extremely biased. Because think about it, if you're going to Costco, the first 100 people, on a lot of days, they only let in people who are, say, older or need help with more things getting it into a cart. So there's going to be bias on a lot of days that these people, that first 100 customers, are a particular group who need more help. So if the question is, I find it easy to load things into my vehicle, well, this group is going to be like, no, you need to make it easier. Whereas their opinion is going to differ drastically from the group of people who might be the last people into Costco before they close. That those are the people who probably just got off of a very demanding job and are quickly grabbing stuff before heading home to go to bed and do it all again tomorrow. That a convenient sample has a lot of bias. Finally, by just deduction, well, the last one has to be D. But we don't want to fall into that trap of just putting an answer because it's the last one available. We want to know that is the correct answer. So, a company breaks their employees into male and female and then select 20 individuals. Well, yeah, that is stratified because we broke up based on a trait. And then we used an SRS in both groups with that trait. So, we've got our multiple choice selected, matched everything up. There's that second part here of label and identify the population and the sample. So looking at this, so every school district in Oregon has to select 10 students to be our state testing champions, and we use their scores to determine how well districts are doing. Well, our population is each school district. And our sample is the 10 students who are randomly selected. So that's for that first one. Someone is doing a giveaway on Twitter where you have to retweet to be entered. How do you hope they are selecting the winner? Well, looking at this, the population here is everyone who entered. The sample, you hope, is you. In reality, this is the winner. Might be you, might not be. We celebrate when it's us. We still celebrate when it's not us because that's the good thing to do. We don't want to be bitter about losing. That's a good way to just not enjoy life. Next up, on the bottom of the Chick-fil-A receipt this weekend was a survey for which I got a free chicken sandwich. Well, the population, at least as far as Chick-fil-A is concerned, the population is hopefully all customers. Maybe let's just generalize for that day. Realistically, you'd want to actually shrink that the population should be customers during that particular time period when you had these employees working, all that. They might break up the population more. I'm going to just generically say customers for that day. The sample is people who fill out survey or who take survey. That they are looking at trying to describe, the group they're trying to generalize is all customers, but they're only getting information from those who choose to take the sample. The first 100 customers entering Costco are asked to take a brief survey. Same thing, and you're going to notice a pattern. Whenever you've got a company giving out a survey to customers, they want to describe all customers. And if we're being idealistic, their ultimate goal is that they can describe all customers ever. In reality, that's just not the case. You've got to pay attention to day of the week, time of the year, time of day even, and who you're talking about. But we'll be optimistic for Costco. They want to know about all customers, maybe for the month. Their sample here is the 100 people surveyed. Just to take a moment to point it out again, this is not a good way to sample. Don't use a convenient sample if you can possibly avoid it. It is the worst way to sample because it is extremely biased. These first 100 people will have a drastically different opinion than everyone else. And pretty much any sort of study where you compare the two, you will see a completely different story between a convenient sample and any sort of SRS. The rest of these options are better. And let's wrap it up. We've got this last one. The population is all employees. Because a company breaks up their employees into male and female. They break off those groups, and then they do an SRS of the 20 males, 20 females. So our sample is the 20 males and 20 females selected. So that is working through this entire review sheet. Make sure if any of it was confusing, talk to friends, watch the video section that was confusing again, come talk to me about it. There are a lot of options available. You can go back to your notes and look at everything that we've done. Lots of ways to get help. This test is going to be on Friday during the all periods day. It's a 1 through 7 day. Classes are 40 minutes each. That means you need to come in. You don't want to be looking at these questions, racking your brain trying to remember them. You want to walk in, get started, finish quickly, and get out. So make sure if you have questions, now is the time to start working on it. I hope you're having a great night. Make sure to get this finished and get your questions answered.